Hey guys, it is Mr. Dave with the RayKitty Creation Workshop, and you are watching the RayKitty Science Project. Thanks for tuning in. I'm excited for today's projects, and we're going to be learning a little bit about science, of course, and we're going to be today talking about chemical change and physical change, and then we'll be doing a little demonstration that may kind of throw you off a little. So we'll be talking about chemical change and physical change. If you want to follow along at home with these demonstrations, the things we are using today are baking soda and vinegar, and acetone and polystyrene, or you usually call it styrofoam, but it's expanded polystyrene foam. Styrofoam is the brand name. So we're using those in our demonstration today along with some ice. And I have here a hot plate, and we're just going to be using this one just to kind of show a quick demonstration with the ice. So ice and these other things here are what you will need if you want to follow along today. As far as cleanup, as far as safety, acetone does have some very strong properties that it can dissolve plastics very easily. Acetone is generally safe. You don't want to drink it, you don't want to ingest it, but if you get it on you, it's actually the same stuff that they use in nail polish remover, so it's not going to hurt your skin. If you leave it on for a long time, it will evaporate very quickly and dry out your skin, so you don't want to leave it on your skin for very long. But if you do come in contact with it, I will be coming in contact with it. I'll be doing that without gloves. That's because some gloves will dissolve in the acetone. So acetone, take the safety precautions you would take with nail polish remover, because it is, as I said, kind of the main ingredient in most nail polish remover. When I'm doing this here, you'll notice instead of my usual little black tablecloth that I have on here, my black tablecloth is a type of plastic that will really make a mess if that acetone gets on it. So I have a plastic that is safe for acetone that's on the table here. So if you are using acetone and you're using it on your brand new table that has maybe one of those printed table laminations on the top, you may want to cover it up with something or be very careful with it. The same thing with your carpet. You don't want to drip it on your carpet because some carpets will respond poorly to it. So with acetone, that is a little bit of safety up ahead. So if you are using acetone, make sure you have an adult with you and make sure that you are taking some precautions not to get that on any plastics. Again, it's safe to touch, but don't ingest it. Don't breathe too much of it. And don't get it on plastics. All right, we good? Okay, baking soda and vinegar, pretty safe. Ice, pretty safe. I mean, unless you have a big chunk and you bonk you on the head with it or something like that, but it's pretty safe. So what we're talking about today is material, our physical change and chemical change to materials, okay? So physical change is when something goes through a different state or a different form of matter. And a physical change can usually be pretty easily undone, okay? It doesn't produce a different product. It produces the same product in a different state, okay? And this is a very, very easy one. Just a simple example. What I have in here is some ice, okay? Ice is frozen H2O, okay? This is not dry ice. This is just some water from the tap at my house, okay? So this is regular H2O or water ice. Now we know if we were to put it on something hot like this, we're getting one steam, right? We're getting that vapor, okay? And that is just water vapor. This is all water, but this water here that's coming off of our hot plate is the water that was in that ice, okay? So it went from one state to another state, which is water, and then up to that vapor. So we see in this one here, this is a physical change, okay? Because if we were to condense that vapor, if we were to freeze that water, it would be right back to ice, okay? So this is a physical change. So I want you to kind of keep that in mind as we're going through these other ones. A physical change is that change in state, okay? So it can be reversed. I could freeze this again if I could scoop it all off of there and collect it all from the air. We're here in New Mexico, so any moisture to the air is a great thing. So I'm going to leave that out there. But this water that's on here, we could freeze it again and have ice. Okay, so this is just a very simple states of matter physical change. Okay, this is not a chemical change. This that was in the air, H2O. This water on here, H2O. This little bitty bit of ice right here is H2O. Yeah, this one right here, yeah, right there is H2O. Okay, so this was a very simple demonstration of physical change. Now, I did use a hot plate in this one. If you are at home, you can take this out. It's getting nice and warm outside. Take some ice, put it on the sidewalk. You're going to get about the same effect. Okay, put it on the asphalt, nice and hot. That ice will melt and dissolve and evaporate very quickly. Okay, so I'm going to get my little hot plate out of the way. And this here was an example, as I said, of physical change. Okay, what we're going to check next is an example of chemical change. Okay, now chemical change is a little bit different. A chemical change happens on a molecular level. Okay, a chemical change is when you have different substances and those substances react with each other to create a new product. Okay, so we had H2O in solid, H2O liquid, H2O gas. This one here, there's a lot of fun to be had with baking soda and vinegar. And we'll get into that one a little bit later. We're going to do one simple one here. But in this particular chemical change, we have an acid, which is our vinegar, and we have a base, which is our baking soda. Okay? Now, if you've done this one before, you know what's going to happen. If you are doing this at home, fun thing to do with this baking soda and vinegar one is to add just a little bitty bit of dish soap. Okay, now I'm not going to do that here today because that's not what we're showing. We're showing a little bit more of just the physical and the chemical change. Okay, so what we're going to do here is to create a new product out of the physical here, this solid, and this liquid. Okay, the new product is actually a gas. Okay, and because I have acetone here, I was going to use that gas to extinguish some candles, but if you've got acetone around, don't set yourself up a nice little candle station for cleaning your nails because that acetone vapor can cause some problems. So with the size here, I decided let's just avoid any possibility of that. So for safety's sake, we are just going to create that gas that's in here. So I'm going to start by putting my baking soda into this one here. Now, if you are making that baking soda and vinegar volcano, right, the classic science project, like I said, you would add some dish soap to this. It's way easier to add dish soap to the vinegar than it is to the baking soda. But I put some baking soda into my container here. The stoichiometry, right, which is the ratio of our chemicals, doesn't really matter. You want to put some, and then you want to put some more. Okay, so when we put this in here, I have this, you may notice, in a tray. This tray here is just to keep it, if it overflows from my container, to not flow all over the table and all over my pants. Okay, so we do have this extra tray here to catch any of the extra material that comes out. Okay, so what I have in this one is vinegar. Now you may notice before I pour out this vinegar that my acetone here is pink. Okay, now acetone is not naturally pink, but what I did was I tinted my acetone so that I wouldn't get them confused, okay? Because you don't want to end up with the wrong chemical. So I just put a couple drops of coloring into my acetone so that I know while I'm up here, hey, this is acetone and this is vinegar, okay? So we're going to go ahead and put some of this vinegar in here and see what happens, okay? So I'm gonna pour this vinegar into the baking soda, and what you're gonna see happen is those bubbles, okay? We have all of those bubbles that are coming up, and those bubbles are actually full of a new product, okay? The new product that it is generating is carbon dioxide. Now, carbon dioxide is one of the gases that we expel when we're breathing. It's a gas that's all over the environment, so it's not a dangerous gas unless that's all you're breathing. You can suffocate in it, but this here, carbon dioxide is heavier than air. Okay, so if you're doing this at home and you don't have that acetone around, something that you can do with this carbon dioxide, this is now filled with a little bit of bubbles and carbon dioxide. The carbon dioxide is heavier than air, so it's actually still filling this container. So we'll see if we can make just a little bit more. I'll put, because I got a little more in here. A a little more baking soda. Remember, the stoichiometry doesn't matter. Pour this in. There we go. We get those nice bubbles. Now, the bubbles, as they pop, remember I didn't put the dish soap in there, so we didn't get that retention in those bubbles. Those bubbles, as they pop, are full of that carbon dioxide gas. The carbon dioxide, I could actually pour, right? Now, you can't see it. It's an invisible gas, but you could actually pour it. You could extinguish candles. That's a fun one to try at home if you're doing some extension activities. What you would have is a small candle. You're creating your byproduct here, which is your carbon dioxide gas. And your carbon dioxide, you can extinguish candles with it. You can do all kinds of fun little things with it. The carbon dioxide is actually the same chemical that they use. Again, I'm a New Mexican, so I call them all Cokes. But when you open a Coke, whether it's a Sprite or whatever, when you open that thing, those bubbles that come out of there, that's carbon dioxide. So that kind of smell that you get, that's that wonderful carbon dioxide gas, because they use that to carbonate your sodas. So I said soda, so it wasn't quite as, Coke with the whole Coke thing. So this right here, I want you to kind of picture this as we're going on to the next one, was a chemical change, because those two chemicals combined, it would be very difficult to separate them. You couldn't separate them. They change molecularly, and we have created carbon dioxide gas. Okay, so now we are going to come over to our... Well, I'll let you decide. Is this one a physical change or is this one a chemical change? Okay, so we did physical change, we did chemical change. Now I'm going to let you decide what's going on with this one here. What I have under my little covering here is a bald guy. Yeah, so I've got a bald guy here. Yeah, I know. If I am going to make this little bald guy here, when I was buying this at the store, my daughter was actually taking pictures because she thought there was a little bit of a similarity there. And believe it or not, as people were walking down the aisle, a guy said, "Hey, he looks like you." Yeah, okay. So I figured, since that's the case, and since we will be doing a little bit here, I'm going to give him a weird little beard like I got. So we'll give him a scruffy little beard. We might as well. My name is Mr. Dave, but I don't want to call this Mr. Dave because then it's a little too spooky. We'll call this one Mr. Dan. Okay, so this is Mr. Dan. All right, so Mr. Dan, let's see how he looks. We'll give him a little bit of eyebrows and things to give him a little bit of personality. If he were, okay, wait, we'll make him like my opposite twin. I'm going to put a spot on his face too. I'll put it on the other side. There you go. And some scruff. There you go. So now we've got Mr. Dan here. And Mr. Dan is made of that polystyrene foam. Okay, now I've got some green. I'm going to give him some green eyeballs. Little green eyeballs in there. There you go. That is way more nightmare inducing. So now we have Mr. Dan. Okay, yay, Mr. Dan. Hi, Mr. Dave, Mr. Dan, Mr. Dave, Mr. Dan. So this is polystyrene foam. Polystyrene is, as I said, we usually call it styrofoam. Okay, so styrofoam is very, very reactant to acetone. Okay, so this is our acetone here. You'll notice when I have it setting in this container, I put a little rag on the top. That's just because it does stink. It wasn't enough to put off a dangerous level of anything, but when it is open, it does have an odor. You don't want to be breathing it a lot, but it's not going to hurt you if I kept it open. Okay, so I am opening that now. This here will react with this. Okay, now what I want you to kind of envision is what the first word that comes to your head when I begin this reaction. Okay, not to your head, to their head. Okay, so what I'm going to do is I'm going to pour just a little bitty bit of this acetone onto our Mr. Dan. Okay, so we'll start with just a little bitty bit. Okay, now you may notice something starts to happen to Mr. Dan right away. He begins, the first thing you thought of, I know you did, was melting, right? It looks like he's melting, just like that ice was melting. Now, the thing about melting is it requires heat. Okay, now this reaction here does not put off any heat. This is actually an endothermic reaction. It actually is cold. Okay, and the reason it's cold is that this acetone evaporates very quickly. So let's have some fun with Mr. Dan here. We are going to go ahead and continue that reaction just a little bit. and we're going to see what happens when we pour just a little bit more of that acetone onto Mr. Dan. Now, as you can see, it is dripping there. You can see kind of into his head just a little bit, and nasty, nasty things are happening. Now, this is a fun one. If you're doing this one to do maybe around Halloween, if you're having a Halloween party, at Halloween time, they have lots of fun shapes of these, and you can get them even at like the dollar stores, and you would spend about $1.25. But yeah, you can get lots of shapes for these ones, and this is a fun experiment to do, like I say, around Halloween time. Or also, another thing that I'll do is I will get the little styrofoam balls, those little round styrofoam balls, and make little snowmen in the wintertime, and you can make your snowmen melt. Okay, now I did air quotes, I'm not an air quote guy, but I did it for a reason, because this is not melting, it is dissolving. Okay, so melting is just like that ice did, heat, it requires heat to melt something. This is dissolving, right? Because we have a reaction there. So let's get a little bit more and see how it goes. Now remember, as I said, if I get this on my hands, okay, it's not going to hurt me. I wouldn't want to dip my hand in it and leave it in there for a long time just because it would really dry out my skin. But now we can see, yeah, now we can see it really start getting pretty nasty with Mr. Dan here. I can actually look right through his head a little bit, and I can, yeah, ew, that is so nasty, so nasty. So it is dissolving into a little pile on the table there, or not on the table, but in my little tray. And so we're going to go ahead and break down the rest of, ew. Oh, I've got, yeah, and now I'm kind of making beautiful art, really. So we're dissolving the rest of Mr. Dave here. Here's the sticker, okay? Now, remember I said certain things react and certain don't. This was the sticker off the bottom of Mr. Dan. It's a paper sticker, and it is not affected, okay? It actually took the adhesive from the back, but the sticker itself is not affected. I'm just going to set that one to the side, and let's see what we can do with Mr. Dan here. We are going to, yeah, there you go. Pour and get, oh yeah, so now we're getting a very nasty, I've got this mouth and nose thing that I've got going on here, and I've got this sludge on the bottom of my tray. We are going to put Mr. Dan into that sludge. We're going to pour just a little bit more of our acetone on here and see if we can dissolve the rest of Mr. Dan into this acetone. Now, what's happening here, okay, with this polystyrene, or this expanded polystyrene, is it is not melting, it's dissolving, but it's staying the same material, okay? So chemical change, physical change, this is the same material as it was when it was in that big old head. The difference is, remember I said it's expanded polystyrene, so expanded is areas without material, and so it has air in it. And so the air bubbles are what are actually dissolving, and it is melting, and we now have this, okay? This very disgusting goo. Now, you'll notice it doesn't stick to my hands, so it's kind of fun to play with, but like I say, if you don't want to expose your hands to it for a long, long time because it'll dry your fingers out. If you have any little bitty cuts on your hand, it's about the same as putting some sanitizer on there. You'll go, whoo, for about a second, and then you'll be okay. But this stuff here that we're actually getting out of, or that was Mr. Dan, that was our nice, beautiful bald head there, this stuff here is the same stuff. This is the same material as that big old head was. So it is not changed on a molecular level. So is that a chemical change? We used a chemical to make that change. Or is it a physical change? Because it's the same material. It's actually a physical change because once this acetone evaporates, this will actually return to a solid, just like it was before. Now, it's not going to turn back into Mr. Dan's head. It is just going to be a lump, okay? If you're doing this at home, what's pretty fun is to let it dry out some, and then you can actually shape it and turn it into a little plastic doodad or gizmo. Usually if you wait until it's kind of dry and you roll it into a ball and then you let it set, then you'll have a puddle. But if you let it dry and then you make it into like a little figure and then you let it set, you'll have a puddle. So it really does not form very well for making a toy, but it will turn into a nice solid piece of plastic or polystyrene. Okay, so it is the same material, but now it doesn't have all that air in it. Now we're going to do it with something a little bit different, but we're going to do the same reaction. Okay, I have all of this acetone in here. I'm going to try and scooch Mr. Dan to the side. Actually, I'm going to see if I can put Mr. Dan in our plastic. I'll leave him right in here. All right, so Mr. Dan's still in there. Poor guy. All right, and I'm going to dry my hands. Okay, I'm just wiping it off now, but if you are doing this at home, you'd probably want to wash your hands before you eat. But you can just wipe it off and my hands are just fine. As you can see, none of that stuck to my hands, so it's kind of a fun little plaything too. What I have here are polystyrene cups, okay? And I have a bunch of them, okay? I have even more, and I have even more, and I have, let's see if we can go all the way off the top of the screen. All the way off the top of the screen, you see, so as far as you know, that goes all the way to space, right? Because you can't see it anymore. So yeah, these go all the way to space, okay? So we have these cups here, and what we're going to do is we're going to put them in there, and we're going to see how much of that acetone it takes to dissolve this many cups. Okay, so I'm going to put them in there. You set the cups into the acetone, and what happens is it begins to dissolve pretty quickly here. And let's get Mr. Dan out of the way. And our cups start to bubble up and dissolve in our acetone. Okay. And we'll see time-wise if we do our all the way to space, because if they go all the way to space, they may take a while. Let's go with this many, okay? We're going to go with this many here, and I'm going to pour just a little bit more of the acetone on there, and we're going to see what happens with our polystyrene cups. Now, this is why if you are using acetone, you probably wouldn't want to hold it in a polystyrene or a styrofoam cup. As you can see, these things are just dissolving down to nothing pretty quickly. Now, in here, we still have some of the bubbles because as you can see, it's kind of bubbling up. That's because it's dissolving so quickly that it's actually capturing that air before it melts. Now, I said melts, before it dissolves. And so what we're seeing now is once it sets in there, those bubbles do go ahead and pop, and then now we have nothing but a liquid. So we'll see if we can get the rest of our cups to go all the way to space. Now, as we're doing this, I will go ahead and just do a little talk through of what was going on. This is a physical change, okay? Because our cups are not going to turn back into our cups are going to turn into a wad of plastic, but they're still the same material. They're still the same thing that they were when we first started, okay? So these cups here, as you can see it dissolving into that stuff there. Now, what's a fun thing to do also if you've got this, if you still have some of those styrofoam packing peanuts, okay? Styrofoam packing peanuts are a really fun one, again, like around the holidays or anything like that, because what you can do with those is you can see how many of those you can fit into a little bitty container. What we're doing now is we're seeing how many of these cups that went all the way up to space we can fit into our little bitty tray of acetone. So as you can see here, I'll scooch it forward so you can see a little better. As you can see, our cups are dissolving pretty quickly here. We're going to dissolve another tower of them in a second. But you can fit a lot of this polystyrene into this acetone because it doesn't have all those bubbles in it. The bubbles are what takes up most of the space. It's just like a plastic marshmallow, okay? A marshmallow, and we'll do some demonstrations with marshmallows another day, but our marshmallow is essentially the same thing as this polystyrene. It just tastes way, way better. Okay, so you don't want to eat this polystyrene, but you can eat a marshmallow. Okay, so what we'll go ahead and stick with that many in here, and I'll show you kind of what we've got. I'm going to wipe my hands off before I touch our cups. We'll move these guys out of the way. So now what I have is this beautiful wad of what was Mr. Dan and our styrofoam cups. As you can see, there is no difference there. This is a fun slime to play with. If you're going to play with this slime, I would probably, if you are doing this one, keep it to the older kiddos because you don't want, like, oh, this is fun, and then, yeah, rub your eyes or anything like that. But it is a fun one, and what you would notice as I said, is this, instead of melting, this is actually very, very cold. It's very cold to the touch. And the more I roll it in my hands like this, the colder it gets. And what happens is if you are here in New Mexico, a lot of us New Mexicans have evaporative coolers. What happens is that acetone evaporates very, very quickly. And as it's evaporating, it's taking that heat with it. It's transferring that heat. And so instead of this being hot because it's melted, it's actually very, very cold. And one that you can do is you can actually take your tray and put your hand on the bottom of that tray, and it is very, very cold. Okay, so it's not cold enough that it's going to hurt you. It's not, you know, your hand's not going to freeze it. I wouldn't try and stick your tongue to this because it's really yucky. But it's not cold enough that it would freeze your tongue to it. It would just be very, very yucky and not very good for you. So this cold reaction is very different than our melting. Okay, so what we have is here is a physical reaction that we created with a chemical. Okay, so this chemical and this, well, this chemical created a physical reaction because this physical change can turn back into the same material. These materials have not bonded. These materials haven't taken apart each other's molecules. It dissolved it to a point where it released the air, and then now it's going to return to its state. So it will be the same material, but without all the bubbles. Okay? So our materials have not changed, so this is in fact a physical change versus a chemical change. Okay, so we have a physical change. We had our chemical change, which was our bubbles creating our carbon dioxide, right? So our carbon dioxide was a reaction that happened with our base and our acid. So this was a chemical change because it actually generated a new chemical. Okay, so even though when we poured this on this cup, we see lots of bubbles, right? Just like those bubbles that we saw there, you see all those bubbles and it looks like it's foaming up and all those wonderful things. Even though you see all those bubbles, that's just releasing the air that's already in there. It's not generating a new material. Okay, so this is a physical change. Okay, this actually generated a new material, carbon dioxide gas, and so this is a chemical change. Our ice that we had on our little hot plate here was a physical change because it was just changing from the state of a solid, right? And a solid is when those molecules are very close together, very tight. Change to a liquid where those molecules can move together a little more freely, into a gas where those molecules can move together very, very freely, okay? So physical change, you have the same stuff at the end. Chemical change, you generate new stuff. And this one here was just a fun example of a physical change that happened because of a chemical. All right, well, that is it for today's RayKitty Science Project. I'm Mr. Dave, and don't forget, science shows you matter.